All right, Algebra 2, 1.7, Day 2, Transformations of Functions, building off what we did yesterday. Today we're going to be focusing on dilations and reflections. Okay, so first the dilation, a transformation that stretches or compresses the graph of a function. If you multiply a function by a constant, so if we have an a value, and we'll get into more of the equations later, it's going to dilate the function. Sometimes it's going to be a whole number greater than 1. Sometimes it's going to be less than 1. If you think about getting your eyes dilated, you go into the doctor, they dilate your eyes. It makes the pupil of your eye get larger. Okay, a reflection is a transformation where a figure, line, or curve is flipped on a line of reflection. Oftentimes that's the x-axis. So if we have a parabola, for example, on our graph that is going up, left end up, right end up, the reflection of it would be now right end down, left end down. That would be the reflection. All right, if it's multiplied by -1. So for example, with this one, if we have f of x equals, and then we have a negative right here, x squared, then that's going to give us the parent function, which would be a parabola, and it's just going to be flipped because right here we would actually have a -1. Okay, remember that the parent function of this would be f of x equals x squared. So all we're doing is multiplying that by a -1. We'll get into a little bit more what if it was a larger negative number in our dilations. Okay, so what this means here is if the absolute value, we're talking about dilation, so the absolute value of a is greater than 1, we're going to get vertical stretch. Okay, so remember a is going to be that number that comes before our x value. So if we have f of x equals a times, if we're just doing a quadratic, x squared, or we could put the h value in there too, x minus h squared plus k. If that a value right here, if its absolute value is greater than 1, it's going to be a vertical stretch. So think about taking a rubber band, and if that rubber band you were holding it was like this, and then we stretch it, it's going to end up looking like this. It actually gets narrower if we stretch it vertically. Okay, so that's what vertical stretch is going to look like. If the absolute value of a is greater than 0 but less than 1, that's what this means right here, greater than 0, less than 1, then it's going to be what we call vertical compression. So that's where we would be taking that rubber band and we're compressing it vertically, so it's going to make it look like shorter and fatter, like that. Okay, so it's going to make the graph look wider. All right, then the bottom two we're not going to really be using, but wanted to put those on the table. All right, so now we're going to do more of what we did yesterday. So the first thing we need to do is identify the family. So I want to give you some time. This would be a good time to pause the video, copy down the equation, and then write these in. So identify the family, describe the transformation, sketch the graph, state the domain and range. So right now would be a good time to pause that video and give that a try. All right, our answers. This is going to be in the quadratic family. Okay, and then remember our form for that is a times x minus h squared plus k. Well, in this case, we don't have an h, we don't have a k, so all we're worried about is our a. Okay, our a is positive, so that means that it's not going to be reflected. So in this case, it is just stretched vertically by a factor of 2. Okay, so that's what that would mean. Then next for our graph of this one, all we're going to do is do our parent function. Okay, because we didn't have an h or a k, so it's not translated at all, our parent function, but instead of it being our normal parabola that goes like that, we are just going to make it skinnier and closer to that y-axis, just like that. Okay. Mine's a little bit shifted to the right. We'll slide that over. So just like that. The space that you have between your y-axis and your graph on each side should be mirrored, should be about the same. So that's why I shifted that over. Okay, then our domain is going to be negative infinity, infinity. And our range, we do have a limit on the range. It's going to be 0 to positive infinity. So that's what that one would look like. Okay, for number 2, we have another quadratic. Okay, and again, we don't have any h values or k values, but we do have a negative. So this is reflected across the x-axis. And it also has a vertical shrink by a factor of 1/2. Okay, so then in our graph, what that would look like is normally, remember, our parabola looks like this. Okay, well, it's flipped, but then it also has a vertical shrink. So now it's going to be wider and fatter. That was not a good drawing. So it's going to go like that. Okay, so where our parent function might, if it was a negative parent function, it might be more of like this. What we've done is we've made it twice as wide, or we've shrunken it down vertically by a factor of 1/2. Okay, now our domain is going to be the same on all these, negative infinity, infinity, and then our range is going to be negative infinity to 0 because it's flipped. So that's what those two would look like. Okay, our next example, go ahead and pause the video here. Give these a try. Okay, first on number 3, okay, this is in the absolute family. So we're thinking that this is going to end up looking like the V. Okay, our dilation, our dilation is a reflection across the x-axis. Okay, and then we also have vertical stretch by a factor of 4. So all we're really doing here is we're taking our y values and multiplying them by a -4. Negative flips it, makes it reflect, and then the factor of 4 stretches it. So normally our parent function would be a nice 1-to-1, just like this right through here. Okay, well, we flipped it. So this would be the flipped version. And then because we have that factor of 4, what we're actually going to end up with, our actual answer would end up being something like this, where it's just narrow. So our final answer should be this purple one right here. Okay, you're going to have a narrower upside down V, really skinny mountain. All right, our range, or well, the domain, first of all, is, like I said, going to be the same on all these, negative infinity, infinity. Our range is negative infinity to 0. All right, and that's why right now, because we don't have any h or k values, that's going to be pretty common here. All right, on the next one, we have another absolute value function. So we're in the absolute family. Hey, it's not negative, so it is not reflected. So we just have a vertical shrink by a factor of 1/2. Okay, so this is going to make it look shorter and fatter, is what's going to happen. So our graph, the original parent function again, goes out 1, up 1, over 1, up 1. So we have to make this look shorter and fatter. So what's going to happen is it's actually going to end up looking like a lot wider V, like that. Okay? And then our domain and range, negative infinity, infinity. Our range is going to be 0, positive infinity, because we have that limit at 0. Okay. Next thing we're going to do is we're going to write the equation, describe, and we're not going to write the equation. We're just going to describe the dilation here first. Okay. So first thing we need to do is recognize the family. This is a linear family. So we have a line that is going, in this case, you can see it's going down 2 over 5. Okay. So that's our slope, down 2 over 5. 1, 2, 3, 4, 5. Okay. So this has been reflected across the x-axis because we have that negative slope. So that's our first thing, is we would say reflected across the x-axis. Okay, and then we have a vertical shrink because I know that 2/5 is less than 1 but greater than 0. So a vertical shrink by a factor, that means we're multiplying by a factor of 2/5. 2/5. Okay, so that would give us the lighter green line. The darker green or blue line, that is our parent function. Okay, so this is some good visuals here about what's happening. A dilation is on the left. So again, if the absolute value of A is greater than 1, then it's going to be stretched vertically. So that would be the orange line. Okay, the blue line is the parent function. And then if it is greater than 0 but less than 1, the green line, it's going to have the compression vertically or shrunk vertically. Okay, on the right, we have our reflection, and that's just talking about if it's negative, we flip it. Okay, but another good reference for you. Okay, this is talking about our h and k values that we talked about yesterday. Remember, a negative h actually moves it to the right, positive h actually moves it to the left, and then the k's are consistent with their signs. So a positive k goes up, negative k going down. Again, just some good images there that go along with each of the references. So now we're able to do all of this all together, okay? So this is an area where I want you to pause this video and give this a try. So we're going to describe the transformation using our A value and our H and our K. Okay, number one, first thing we need to describe is the family. So this is a quadratic. Okay. Then we do not have an H value here because the X is not in parentheses. So that means it's not translated left or right, but it is translated 1 unit up. Okay, and then we have vertical stretch because we have 2 as the A, vertical stretch by a factor of 2. Okay, then our graph is going to be over or up 1. Okay, and then we know it's a parabola. We have a vertical stretch, so instead of it being our normal parent function, it's going to be a little skinnier and narrower. Something like that. Okay, and then our domain is still going to be negative infinity, infinity. Our range, okay, now we have a different limit because we've translated it up, is going to be 1 to infinity, because now it's not sitting right there on the origin. Number 2, we have an absolute value function. Okay, and on this one, looks like we have a lot going on, but right now this would be plus 0, so this would actually be our k value. So we're not going to move it up or down. That's why we don't need that there at all. This is our h value. So our translation, remember, negative means that we're actually going to the right. Okay, so this is translation right 2 units. and a vertical shrink because it's of a factor of 1/2, or by a factor of 1/2, and reflected across the x-axis because we have that negative. Now if we were to graph this, you remember that our absolute value parent function is the v, like this, okay? So first of all, we need to reflect it, so it's going to be upside down. So our arrows are going to be pointing down, falls on both sides, all right? And then it is moving to the right 2. I don't move it vertical at all, so I'm just going to go from the origin 1, 2. So the vertex of my graph is going to be right there. And then it says we have a vertical shrink, okay, which means it looks fatter. It's going to look wider. So it's going to be going like this. Okay, our domain is negative infinity, infinity. Our range has a limit, but our limit is on the positive side. So it's negative infinity to 0. And then make sure we put a bracket there. That's what those two should look like. Okay, 2 more. Go ahead and pause the video. Give these 2 a try. Okay, on the left, number 3, we have a quadratic. Okay, and our transformation is reflected across the x-axis. Translated to right and 1 up and vertical stretch because it's a number greater than 1, absolute value is greater than 1, by a factor of 2. So that means it's getting skinnier. So it's going to be flipped upside down because it's negative. It's moved to the right 2 and up 1, and then it is a little bit skinnier because we have that vertical stretch. So let's go ahead and draw what we think our graph would look like. First thing you want to do is figure out where your vertex is going to be. So we're going to go to the right 2, 1, 2, and then down 1. So my vertex is going to be right here. And remember, it's going to be going down, pointing down, because it has the negative right here. And then it has that vertical stretch. So it's going to be a skinnier V. Like that. Okay. Our domain, still going to be negative infinity, infinity. Our range is unlimited to the negative side. To the positive side, it has a limit of negative. I moved that the wrong way. Should be up 1. Just caught that. That's why it's good to end up adding our range. So this actually should be up here because we said up 1. Okay, so our range goes up to a positive 1. Sorry about that error, guys. Glad we caught it before we published the video. Okay, then on this one, we are an absolute function. Okay, and we have a reflection across the x-axis. It's going, now because it's a positive 5, it's actually going left 5. We're going left 5 and up 2. And then we have a vertical shrink by 1/2. A lot going on there. Each piece is a valuable piece so that we can create this graph. All right, so we're going to the left 5. 1, 2, 3, 4, 5. We're going up 2. 1, 2. Got it right this time. All right, then we know it's going to be upside down because it has our negative, and it's an absolute value function. So it's going to be a V. And then we have vertical shrink, so it's going to be wider. It's going to look just like that. Domain, unlimited. Range, on the negative side, unlimited. On the positive side, a limit of 2. Okay, now this is the last thing we're going to do here. We want to describe the translation. The parent graph again is in blue, and then you can see our function there on the left. So what we've done here is we have translated this 3 units left, one unit up. We have a reflection across the x-axis, and then we have vertical shrink by 2/3. So what we did is we took this right here and we moved it 1, 2, 3 to the left, 1 up, and then we took the graph and we reflected it across the x-axis, and then we made it wider by multiplying it by a factor of 2/3. We shrunk it vertically. Okay, now this one, we don't have an equation for us, so we have to use the graph to figure that out, okay? So first of all, the first thing you want to notice is that we're not on the origin, right? So we're going to have an h value, we're going to have a k value, okay? We also need to notice right away that this is an absolute value function. So we're going to start out with f of x equals. Now, one thing that I like to do sometimes is just below or off to the side, my h value, I'll just write down here. So I know my h, it's going to the left, so it's going to have to be positive, is 1, 2, 3 units. So it's going to be 3, a positive 3. My k value is going to be a negative because it goes down. 1, 2, 3, 4. So it's going to be a negative 4. All right, then for my a value, we can use the line here. Normally, our absolute value would go right through here, 1 to 1, just like that. Well, it doesn't. It goes up 1, 2, and then it goes over 1, 2, 3, 4, 5, 6. Or if you notice it goes up 1, over 1, 2, 3. So my a value is going to be 1/3. Okay. So then I'm going to have 1/3 times, or not times, the absolute value of x, and my h value is going to be 3 plus 3, and then minus 4 because my k value, and that's going to be my equation for this graph. Great job today, guys.